Okay, in this lecture, I'm just going to look at two of the exercises at the back of chapter 1. And we are specifically going to look at number 5 and number 7. So for number 5, a supply company offers the owner of a new business 20,000 rands worth of fixtures on credit. The money is to be repaid in 2 payments. The first payment is to be made exactly 2 years after the credit is granted, and the second payment exactly 5 years after the credit is granted. Assuming that the interest is calculated at 20% per annum compounded monthly, find the value of each payment, given that the second payment is to be twice the size of the first. So if we make a timeline of this, at time t0, there's an inflow of 20,000 rands. Then at time t2, there is a payment, and let's call that payment x. And because it's a payment, I'm going to make that a negative. And then at time t5, there's a further payment, and that payment must be twice the payment of the first one. So it must be twice the size of the first. Therefore, that payment is to be 2x, and it's negative because it is an outflow. And we would like to solve for x. Now, if we get a problem like this, we can make use of the method of the net present value to solve for x. We can't just take the 20,000 divided by 3 and in that way solve for x. We have to take into account the time value of money. So that means that we have to move my 2 payments to time t0 and then set them equal to 20,000 rands. So this is my 20,000 rands, and my 2 payments must be equal to that 20,000 rands. So my first payment, I move it back 2 time periods, and my interest rate is 20% per annum compounded monthly, so that's why I divided by 12. And after 2 years, 2 years is the same as 24 months. Because we are compounding monthly, we have to have it to the power negative 24, negative because we are moving backwards, and 2 years is the same as 24 months. And then also for the second payment, okay, and 5 years is the same as 60 months, so that's why it's a negative 60. I'm moving it backwards 60 months to get to time t0. And now you can go and solve for your x. So if you solve for your x, I got for my x equal to so that will be my first payment, and my second payment will of course just be twice that. So my second payment is just twice the first one, and that is the okay. Of course, you could also have done this slightly different. You could have said that, let me just make that in a different color. You could have set the net present value equal to 0, and then your x value would be negative. Okay, and then solve for x and you would get exactly the same answer. Okay, so that was for number 5. If you look at number 7, the time diagram indicates outflows and inflows for a project. Determine the net present value of the project, assuming an alternative investment option could yield an interest rate of 12% per period effective. And then based on the net present value, indicate which would be the best option. Okay, so we can do this by hand. So if we want to get the net present value, so the net present value is equal to the following. It's the outflow of 15,000 at time t0, and now we move all the inflows and outflows, we move it to time t0. So the first is the outflow of 5,000 rands, and I move it back one time period. Then the inflow of 7,500. And this outflow, we move it back 3 time periods. Then an inflow of 8,000 rands. And lastly, a final inflow of 15,000 rands. Okay, now you can calculate this by hand. It is a little bit tedious, but you can do that. If you do that, you should get a net present value of -601. And because this net present value is negative, we would say that we would reject this investment option. We can also, because the inflows and outflows are all spaced equally, and they're all one time period in between the inflows and outflows, we can also do this on the calculator. So I would suggest that you redo this example and use your calculator, your financial calculator, to get the net present value. You should get this -601, and then also use it to get the internal rate of return. Remember, for the internal rate of return, we do not substitute that with the 12%, but we have the internal rate of return for all the interest rates. And then we solve for the internal rate of return if the net present value is set equal to 0. We cannot solve that by hand. We have to make use of our financial calculators. And when I used my financial calculator, I got for the internal rate of return 11.0361%. Now, if you compare this internal rate of return to the alternative interest rate of 12%, you can see that it's less than 12%, and therefore we will reject this investment option. Again, we get exactly the same conclusion than when we use the net present value method to evaluate the project. So you should always get to the same conclusion, no matter whether you use the net present value or the internal rate of return methods.